Correct. So that's how we use multivariate analysis to control for confounders. We put those confounders in the model. We view, we see, we observe how those confounders, how putting those confounders in the model changes the slope, the relationship between the predictor we care about and the outcome variable. Now I'm going to talk about another function of multivariate analysis, which is simply to improve prediction. Sometimes our goal is to be able to predict what is it that tells us who's going to like Obama or who's going to do homework, whatever we're trying to predict. Putting more variables in the model will often improve predictions, because if you know more about somebody, that might improve your ability to predict how they're going to fare on a certain test, or how they're going to fare in terms of their likes or whatever the problem may be. Recall we had this example of political leaning and Obama. So not surprisingly, if your political bent is more liberal, that was pretty strongly related to how you feel about President Obama, who of course is a Democratic president. It's more on the liberal side of things in the US. The R squared here was pretty big. It was 61%, saying that your political bent explains about 61% of how you feel about Obama. Again, not surprising, but then you might say, okay, I've collected a number of other variables besides these two, and maybe there's something else in my data set that also helps to predict who's going to like Obama, above and beyond politics. Is there something else we can add to this model to refine, to figure out what is going to predict who likes Obama? Well, I kind of hunted through the data set, and some of the things I'm finding might be due to a type 1 error, because I looked through the data set to find what other things are associated with ratings of Obama, but I found some that actually make pretty clear sense. There's a good reason why these things might be associated, so they're not surprising. I'm here showing you the univariate results from other things that seem to be associated with your ratings of Obama. These are now simple linear regressions with one predictor in the model. So the outcome here is Obama rating, same outcome as before. I did a simple linear regression model with the ratings about President Clinton, a former US president who is also fairly democratic. You can see that when I ran that model, the beta coefficient is 0.4. So every 1 point increase in your ratings of Clinton was associated with a 0.4 increase in your rating of Obama. So there is some association here. The p-value is definitely significant. And that kind of makes sense. If you liked Clinton, you probably liked Obama. Notice that this is a simple model, and people who like Clinton are likely Democrats. People who like Obama are likely Democrats. So this could be due to, this simple regression could be due to confounding by politics. I also wondered if healthcare, how you feel about the new healthcare law passed by Obama. Some people call it Obamacare. If you were in favor of that healthcare law, if you rated it highly, maybe then you'd also feel favorably towards Obama. And indeed, I do find a relationship here. So every 1 point increase in your ratings of the healthcare law on a scale from 1 to 100 increased your ratings of Obama by 0.3. So it's not quite as strong as the Clinton effect. Neither of these is as strong as the politics effect, but it's still highly significant. Of course, we always want to graph things, so don't forget to graph. You need to graph. So I just did simple graphs here between, here's the healthcare law on the x-axis, on the left-hand side here, and the Obama rating. So you can see there's kind of a moderate association between your feelings about healthcare and your feelings about Obama. Also with President Clinton, more favorable ratings of Clinton tended to correlate with more favorable ratings of Obama. They're not as strong as the graph I showed you for politics in Obama, not surprisingly. But it seems to be some stuff going on here. I then took all 3 of those variables, healthcare, Clinton, and politics, and put them into a single regression model predicting ratings of Obama. And here's the results of that model. So now I've got a multivariate regression model with 3 predictors in there: your political bent, your feelings about healthcare, your feelings about Clinton. Here's the results. Again, here's the parameter estimates, here's the p-values, which is the thing we're going to focus on. What I can see here is that the politics is dominant. So the best predictor of your feelings about Obama is still politics. The beta coefficient is 0.56. By the way, all of these things are rated on a scale from 0 to 100, so the units are somewhat comparable here. So 1 point increase in your politics bent towards liberal increased your feelings about Obama by 0.56. Healthcare doesn't have remember the relationship with healthcare was a beta of about 0.3 before. It goes down to 0.14 once I account for politics and Clinton, but it's still bordering statistical significance, and there's still a little bit of an effect. So in addition to your politics, if you liked that healthcare law, it seems to add a little bit to your prediction about how you'll feel about Obama. The beta is 0.14, so it's not huge, but it's still maybe a little different than 0. Also, interestingly, there also appears to be an independent effect for Clinton. So even after you adjust for your political bent and how you feel about the healthcare law, there's still some effect left over, some additional predictive power that you get by Clinton. There's sort of the Clinton halo here. This must be why they always wanted Clinton to come speak at all of the Obama rallies and things. People who like Clinton do tend to be more likely to like Obama, independent of their political bent and independent of how they feel about healthcare. So you're eking out a little bit of additional predictive power here by throwing Clinton in the model. Now I'll show you the R squared here. So remember, the R squared just with politics alone in the model was 0.61. It goes up to 0.69 when we add healthcare and Clinton to the model. We're not doing that much better. We're only explaining about 8% more of the variance in feelings about Obama. And in fact, if we account for the fact that we now have 3 predictors in the model, and whenever you add an additional predictor in the model, your R squared always has to go up even by just a little bit. So sometimes people would prefer to focus on a measure called the adjusted R squared, which accounts for the number of predictors in your model. We want to also always be parsimonious, put the fewest predictors in our model that give us the most bang for our buck. So it's probably better here to consider the adjusted R squared. It's still, the adjusted R squared of 67% is still higher than 61%. So we're increasing how much of the variance we can explain here by about 6%. We're getting a little bit better on our prediction by also considering the independent effects of people's feelings about healthcare and people's feelings about Clinton. Those things do seem to independently, to some extent, predict feelings about Obama over and above politics. I've also written here just the final model out so that you can see the final model written out. And we can use this model, which I've written out here, to actually predict for a given person. If I knew your political rating and I knew how you felt about healthcare and I knew your rating for Clinton, I could predict how you were going to rate Obama. So let's take a particular example. What if I had a person who had a political leaning of 70? This means that they are somewhat liberal. They're on the liberal end of things, but not totally liberal. Remember, this is on a scale to 100. Their ratings of Obamacare were 90, so they're really in favor of the healthcare reform in the U.S. It's again out of 100, so they're very in favor of that. And their rating of Clinton was kind of modest, 60, so it's favorable but not super favorable. We can take these individual values for a given person, for a given individual, and plug them into the model to see what their predicted rating for Obama would be. We can predict how they might rate Obama. So the predicted value, again, I will sometimes abbreviate that as YI hat, meaning that's our predicted value, is equal to our intercept here was 5.9. We got an additional 0.56 points for every 1 unit of politics, so 0.56 times your political bent. And actually, let me just plug in the number here. So the number here, this person's political bent was 70, so we can just plug that right in. This person's rating of Obamacare was 90, and the slope for Obamacare for healthcare was 0.14, so we can do 0.14 times 90. Plus, the slope, the beta coefficient for Clinton was 0.26. We can multiply that by their actual value for Clinton, which was 60. You can multiply all of this out. You'll find out that their predicted rating for Obama is 67.7. So not super high, definitely on the favorable end, but not as high as some of the values we saw in the data set. So that's how you do prediction for an individual based on a regression model. We, of course, also want to test the assumptions, so we should do some kind of residual analysis, as I talked about in the third module for this week. One of the easy ones that you can do is you can just calculate the residuals. The computer will calculate the residuals for you. So these are the predicted values minus the observed values for ratings of Obama. The computer will do this automatically. This graph was automatically generated for me. I can then take those residuals and plot them in a histogram and see whether or not they follow a normal distribution. The residuals should follow a normal distribution. And indeed, it looks really good here. It looks like it follows a nice normal distribution. So even though the ratings of Obama, the outcome variable, didn't perfectly follow a normal distribution, it was just slightly off because of the central limit theorem, the means very nicely follow a normal distribution, and we adequately meet that normality assumption, even with a sample size of just 50 here. The computer also generated for me some residual plots, so each of the predictors graphed against the residual for every person in the data set. Remember, we're looking for random scatter around 0, and it looks pretty good here, so that we're not seeing any evidence that we violated any of the assumptions of linear regression. I'm going to just do a second example just for fun. Since I've been looking at the healthcare reform in the US, what some people call Obamacare, can we also take the variables in our data set and try to predict what things predict that you're going to like the healthcare reform? So now making healthcare reform, your ratings on that, the outcome variable. Well, obviously, since we already saw that if you liked healthcare, you tended to like Obama, it makes sense that if you like Obama, you're probably also going to like healthcare. So we can put that in the reverse, making Obama the predictor here, and healthcare, of course, is the outcome here. So I just did a simple linear regression here. I did a plot also, and you can see that indeed, not surprisingly, that Obama, your feelings about Obama were strongly related to your feelings about healthcare. I then was also looking in the data set for other things that might predict your feelings about healthcare. Another one that makes a lot of sense is politics. So if you're more liberal on your politics, indeed, that was associated with you liking healthcare more. And that was statistically significant at the 0.05 level, not surprisingly. The Democrats tend to support that more. Of course, as I talked about before, it wasn't perfect here. There's definitely some strong liberal Democrats here that don't like the healthcare, and there actually are some strong Republicans here that do like the healthcare. So it's not perfect, but there is some association there. Another interesting one that I found in my data set is how much exercise you do. Now, this could completely be a multiple testing issue, a type 1 error. It could be a false positive. So I kind of look through my data set for things that predict your ratings of healthcare. Exercise happened to pop up, but since I've now looked at many predictors, potential predictors of healthcare, there's bound to be some that pop up as statistically significant just by chance. On the other hand, there might be some good reason to believe that people who exercise a lot would like Obamacare, would like the healthcare reform in the U.S. The healthcare reform in the U.S. tends to focus on preventative medicine, and people who exercise a lot obviously may support that. So it's not unreasonable that these might go together. Here's the plot. Here's the actual linear regression model. So exercise was in hours per week. So this regression coefficient represents that if for every 1 additional hour of exercise that you did per week, your ratings of the healthcare law seem to go up about 2.5 points, and it is statistically significant. So those 3 variables seem to predict your ratings of healthcare in the univariate picture, that is 1 at a time. I then want to put them together to see if we overall can predict with multiple variables who's going to like the healthcare law in the US. So I put them all into a single multivariate model. So here is the result of that model. Again, you're going to focus on the parameter estimates. That's our model, and the p-values will tell you whether or not those betas are significantly different from 0. Well, looking at that model, you'll notice that Obama and how you feel about Obama was actually a stronger predictor. It kind of trumped your political bent. So once I put politics and Obama both in the model, Obama stands out as being a pretty strong predictor. A 1 unit increase in your feelings about Obama increased your feelings about his healthcare law by 0.5 points, a half a point. But politics is essentially down to 0, 0.039. It's essentially 0, non-significant. So there wasn't any additional predictive power for politics once I know how you feel about Obama, which of course has a lot to do with your politics, but seemed to trump politics here. Once I know how you feel about Obama, then I was able to, I can predict how you might feel about healthcare. But additionally, knowing how somebody's political leanings are above and beyond how they feel about Obama doesn't seem to add any predictive power to this model. The exercise does, though, So your exercise, how much you exercise, does appear still to be strongly related, independent of how you feel about Obama. So somebody who maybe doesn't even like Obama, but is a strong exercise, likes to exercise and likes preventive care, might be more likely to like healthcare regardless of their political bent or their feelings about Obama. So interestingly, in this one, the R squared is not super great. So the R squared here turned out to be 35%. So we're only able to explain about 35% in the variability of how people feel about healthcare. And actually, again, better to look at the adjusted R squared. The adjusted R squared is 30%, accounting for the fact that we've got 3 variables in our model. So we're able to explain about 30% of the variance, which isn't as good as explaining. We did much better on explaining who likes Obama, but we've explained some of the variability. If you, again, look carefully at politics, you see that there really isn't any predictive power for politics. Once I've got Obama and exercise in the model, of course, again, Obama and politics are strongly related. We've seen that throughout this week. So those, we would call those sort of collinear. We'd call them highly correlated. And so when you put both two highly correlated things in the model, it tends to be that one of them is going to dominate. So Obama tends to dominate here. Once I've accounted for Obama, there's no additional predictive power for politics here. So I'm actually going to drop it out of the model because it's not adding anything. There's no independent effect of political bent after accounting for your ratings of Obama and how much you exercise. So we're going to just drop it from the model. My final model, therefore, will include just how much you exercise and your feelings about Obama. Here's my final model. My R squared is still, it's 29%. It only goes down just slightly when I drop out the politics from the model. I'm able to explain 29% of the variance here. And of course, you always want to test your assumptions, do your residual plots. So I'm showing you here the residual plots for the predictors and for this particular model.